Dr. Ben Newman. I study coronaviruses for a living. Let's try to answer your questions with papers. So this question is actually about a paper. So boom, yeah, the paper actually contains all the answers. So this is from Rick. Hello again, Rick. Has Ben seen this article? Would he care to comment? And it's a link to an article. Fine, yeah. The answer is no. I had not yet seen that one. I'm still like a week behind on digging through bioRxiv, and if it doesn't show up there, I rely on popular media coverage and you find people in the Facebook group to pick these up and bring them in. And yeah, interesting. So what it's talking about is a little tiny version of an antibody. So antibody is normally a molecule that's kind of like this, and it's got a stem down here at the bottom, and it's got two little grabby parts at the top. What they're doing is essentially taking just this little bit, just the top of one of the arms, cutting it off, and just using that little grabby part to stick all over the coronavirus and effectively neutralize it. Yeah, stop it from growing. It's basically how antibodies work, but what they're saying is it avoids some of the potential problems with antibodies. And so the problems are things like they're called antibody-mediated enhancement. This is when you can have just the right amount of antibodies. Not too little, not too much, just right in the middle. And occasionally you will have the antibody will stick to the virus, and some cell will come along and grab onto the antibody and then get all activated and bent out of shape. And you'll actually get some damage because you made a partial immune response. Yeah. But if there's a really good immune response, it's usually enough that it drowns that out, and that doesn't really happen at a meaningful level. So what they're doing is they're cutting off the bottom of the antibody. Now, the bottom of the antibody is the part that all of those cells will recognize. And they confirm in the paper that the normal cells that should bind to this do not bind to this and are not activated. So potentially this is, a way to make something like an antibody that kind of works like an antibody but doesn't have some of the potential downside of an antibody. Right now from the convalescent plasma, it doesn't seem to work super well. That's like putting a lot of antibodies from somebody else into you. It doesn't seem to work super well, but it doesn't seem to be actively hurting people either. So yeah, there hasn't been a lot of evidence so far that partial antibody responses give anything other than partial protection. Although we know from animal experiments and other coronaviruses, this is a thing that totally happens sometimes in nature, and it is very good to be careful and keep an eye out for it. So what have they done? All right, they've taken the heavy chain variable domain, if you've been through immunology class, which is this part essentially, and they've figured out that this is enough. It actually does the binding all by itself. Normally there would be, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total domains. They're taking one of those domains, so effectively 1/12 of the entire protein, stitching a little bit onto the bottom of it, I think maybe to hold it together and keep it in shape. Because normally the rest of the molecule has to be there in order for the top bit to have the right shape to do its job. So they either got lucky or they figured out a way to do this. Either way, hats off to them. That's really neat. And this is a thing that could work. Now, what are its limitations? One, it's recognizing a couple of very specific spots on the virus. I think I remember reading it could, like different parts of it could hit 2 spots or something like that. Either that or it's able to bind 2 at once, but I think it's not. I think it might just hit 2 spots right next to each other. If the virus changes at one or both of those spots, and this virus is always changing, then all of a sudden you don't have a drug anymore. You just have an expensive thing you can put in your bloodstream that probably won't do you much good. So that's a potential risk. You would need to come in with not one of these, but like 3 or 4 of these at the same time, aiming at different parts of the virus. And then, I think they could have some effect. The other thing is that it is a reasonably big protein, a lot smaller than antibodies, and we can use antibodies as therapy. But the problem is going to be that it's going to be seen as a protein by the body. It's going to be broken down as if it was any other protein. And so it may not last long. You might have to have like an IV drip, I think, to put this in. And I'm not sure of any other good way to do that. And you might have to go back repeatedly for IV drips. But yeah, it looks like a thing that could be a useful tool for helping out people that are already in the hospital. Probably more useful than convalescent plasma, because this one we know hits a specific part of the virus, and it's the important part. So yeah, any hit should be good news for the patient and bad news for the virus. That's the idea. So, promising, interesting, pretty good science. Yeah, why not? I like it. Thanks very much for bringing this to my attention. And yeah, thanks for very much. This is Ask Dr. Ben.